All right, so up till this point, we have only been solving for one variable. So I give you an equation, there's one variable in that equation, you solve for that one specific variable. So in this chapter, section in chapter 2, you are going to see that we're going to have more than one variable in an equation. So we might have 2 or 3 variables in an equation, and that's what we're going to be solving for in chapter 2. So there are 3 different parts to chapter 2. So I'm going to break it down into 3 different lessons. So you'll have one on Tuesday, one on Wednesday, one on Thursday, all very small snippets, so that way we're not doing a whole big lesson on one day and then kind of being able to work with it. So it'll be kind of like we did this past week, where we did like 5 minutes of notes and then you worked for the rest of the period. So same idea, that's what we're doing in this. So solving for a specific variable, you are going to want to make sure that you're taking notes, so that way you can use them on the knowledge check on Friday. So when we solve for a specific variable, if I'm going to give you the example of 4m minus 3n equals 8. And I want you to solve for m. So when I'm saying solve for m, that means I want to isolate, or I want to get the variable m totally on its own. So when I say solve for x, we're getting x totally on its own. Here I'm solving for m. So we're just going to kind of forget about the fact that we have another variable in here. What we're going to do is we want to isolate m. So we're isolating just like we would. So if we were given the variable x and it was the only one there. So I'm going to add, sorry about that, let me undo that. I'm going to add that 3n, because it's the opposite, to both sides. So I can't put 8 and 3n together because it's not a like term. They're not, they don't have the same variables. So I'm going to have 4m is equal to 8 plus 3n. So I've started to isolate this m variable here. I undid that 3n, that extra 3n on it. So now I just need to get rid of that 4. So when I get rid of the 4, I'm going to divide both sides by 4. But when I do that, I have to divide absolutely everything by 4. I can't just divide the 4 and the 8. So I have to divide everything. So that gets rid of my 4, and I'm left with m on one side. 8 divided by 4 is 2. And 3 and 4 do not divide evenly, so I'm going to be left with 3 over 4n. And that's going to be my answer. I'm not doing anything else with this. I know I still have another variable here, but I don't care because I was only told to solve for m. So we are going to go ahead and let us look at one more together, and then you're going to go ahead and go through the worksheet that is going to be posted with this for practice. So now you're going to have 3x minus 2y is equal to xz plus 5, and we want to solve for x. So this time I have 2 x values here. I have an x here and I have an x here. So first thing I'm going to want to do is I want to get them onto the same side. So when I want to move them to the same side, because xz is positive on the right there, I'm going to subtract it from both sides. I don't have any like terms here, so I'm going to just have to rewrite it and add it to the end of that strip. So I'll have 3x minus 2y minus xz. So that's because I don't have any like terms, and I'm going to have 5 left there on the end. So next, I have this extra 2y that does not have any x's on it, and I need to move that over to the other side. Because it's being subtracted, I'm going to add it. Because they're not like terms, because 5 and 2y are not like terms, I can't put them actually together. I can just have them sitting side by side. So now I'll have 3x minus xz equals 5. And this is where the tricky part comes in. So we'll be working with this more later in the year, but I wanted to make sure that I gave you an example like this because you are going to see it more. So what happens here is I have an x term in both of these parts. So what I'm going to do is I'm going to say I'm going to combine them together and pull them out. So I'm basically undistributing. So they were distributed in, so I'm going to go backwards and do the opposite. So what I'm going to do is I'm going to take that x and put it out front. And if I was to multiply x by 3 minus z and go back up to the beginning, and I'll show you what happens here, I would get 3x minus zx or xz, either way, and that's exactly what we had up here at the beginning. So I'm going to go ahead and keep on going here. So that is equal to, and this should be plus 2y up here, 5 plus 2y. So now that I'm at this point, if I was to actually solve for this then, because remember I just want x totally by itself, I'm going to divide that 3z off of the x. And since I'm not dividing by a number, it's going to be a lot easier just to leave this as it is. So my final answer then is going to be x, because those canceled with each other, is equal to, and I'm just going to leave this as one big fraction, so 5 plus 2y divided by 3 minus z. So like I said, that one's a little bit trickier because you have that undoing of the distributive property here, but overall that's all you're doing. Hopefully that kind of makes sense. You won't see very many problems like this. I'll probably only give you one to try. Otherwise, you'll see mostly something very similar to that first example that we went to. If you have any questions, you can email me, leave a comment on the post, leave a comment in the assignment, any of those places. I would suggest leaving a comment on the post so that way your classmates can see it as well as the answer, because they might have the same question as you. So have a great rest of your day and make sure you complete the worksheet as well.